Okay, so we have our last one of these, which is by far the hardest. If you read through there, it tells you that you have a cone and you're looking for the volume. So you're definitely doing volume of a cone. The volume of a cone formula is V equals 1/3 pi r squared h. Now there's a problem here. I can't take the derivative with all three of these variables, so I have to condense one of the variables. Volume's fine, but if you read through the problem, on the top line it says the radius is 6 times the height. Now we need to use this fact where we can take the derivative and just have two terms. That way we don't have to use a product rule. We can just have two variables. But before we change everything to one letter, we have to make sure we change it to the right one. On the bottom of the example, it says the height is increasing at 2 inches per minute. Now what that means to me is that over here I have to have a dH dt. Now I know I'm jumping to the end just a little bit, but it lets me know I have to have a dH dt. So since I have to have an h in the problem, I have to keep this h. That means that before I do any calculus, I need to do a substitution. Volume equals 1/3 pi times r squared h. All of that is fine. I can't have an r. So, since I can't have an r, I need to replace r with 6h. Because it tells you that the radius is 6 times the height. So now then, if I simplify this expression, then I just have two variables, and then I can get to work on my calculus. So this would be 1/3 pi. Okay, now 6 squared is 36. H squared times h. So let's clean it up. 1/3 of 36 would be 12 pi. H squared times h would be h cubed. Now then, that to me is the hardest part of the entire problem. So that's the bad part. Now then, now we can finally take the derivative. We're going to take the derivative of both sides with respect to t. So the derivative of v would just be 1 dv dt. Over here we're going to have 36, bring your 3 down, pi h squared dh dt. Now, the calculus was easy. It was the algebra that was hard. So if I look back over here, I'm going to need a dH dt, I'm going to need a dV dt, and I'm going to need an h. So those are the things that we have to fill in. Okay, here we go. Sand is leaking. The radius is 6 times the height. We got that. Find the rate at which the volume is increasing. Okay, that's what I don't know. dV dt I don't know. And it tells me when the radius is 3 inches. And the height is increasing at 2 inches per minute. Okay, so this 2 right here is the rate the height's increasing. But unfortunately, it told me that the radius was 3. Doesn't tell me what the h is. So let's go back up to the top. It tells me that the radius is 3. So let's plug that in here. If the radius is 3, and that equals 6 times the height, then we could divide both sides by 6, and 1/2 would equal the height. Now then, so we knew the radius, but we didn't know the height. So I just plugged that into my radius formula that I used earlier, and that's how I got the height. Okay, dV dt I do not know. But this would be 36 pi. H is 1/2 squared, and dH dt is 2. Okay, I ran out of room, so I'll raise it up. dV dt would equal 36 times pi times 1/4 with a 2 on the top. So that would equal 72 pi 2 times 36 divided by 4. So that would go 1 time, 18 pi. Now volume is measured in cubic units, so it would be cubic inches per minute. I'm more concerned with the 18 pi.